last year. And at the beginning, like everyone else, I was kind of, a GPT wrapper, not using GPT primarily, but using one of the frontier models, and we constantly had to deal with kind of, the migration, the API kind of changing, or the provider changed their policies. Some content suddenly is not kind of, allowed, or the kind of the output changed drastically. And at one point, I'm like, I want to save cost. Our customers care about privacy. And I also don't want to deal with all the migration constantly. So how can I maybe have a more dynamic routing solution or vendor management in terms of kind of, building AI applications. Hence, I started to kind of put together kind of, a smaller version of this in our applications. Basically, we are kind of, embracing the culture that people will be use multiple models in the future, and try to resolve or remove the trouble of constantly having to manage the routing. I know a lot of companies are using static routings now, but what we're trying to do right now is be a sort of a middleware or infra layer that handles that for people, especially for the companies that are small or doesn't have the expertise to handle the routings. Hence, then we kind of, started to open source some of the core logics and started to receive some really positive feedback from the community, and also, of course, getting some of our potential clients in the pipeline through the open source project. So this is kind of, where this talk come from, break the cloud lock-in. And we're kind of, together trying to envision building an adaptive intelligence orchestration with DIO, which is kind of this distributed intelligence orchestration. And for this talk specifically, I also want to try something new that I recently started to kind of, tap in is I started to use my AI avatar to kind of synthesize some of my voice and kind of, making some videos and trying to see if that kind of gives a better or more interesting mix of my talks. But yeah, let's get started to meet my kind of AI twin sister.
Hi, everyone. I am the twin sister of Snow, who speaks better English. Snow is the founder and CEO of Agentic, an AI as a service company. She built Agentic with the mission of bringing Silicon Valley craftsmanship to elevate the future of software ecosystem. Snow's background is rooted in hyperscale architecture, from building systems for billions at companies like Meta. She's had the privilege of driving critical initiatives, from architecting the rewrite of Messenger Lightspeed to the first intelligent security platform. Her expertise is bootstrapping a product from 0 to 1 and scaling it from 1 to 10. Snow is more than happy to chat more about the fun stuff that she has done over the years if anyone is interested in catching up offline. But now, let's quickly go over the agenda of this DIO workshop.
Oh, and then something that might be an interesting context is how I kind of, got to know the organizers for this Android developer meetup is I actually started to do open source. Actually, I started my career in Android development like 15 years ago on G1, where back then I was the expert in lint. So I don't know if some of you have been in the industry long enough or kind of, got your hands dirty in static analysis check 10 years ago. You probably see me in a lot of conferences on the Android side. And that's why I'm still really active in the Android community, and that's why I'm still really passionate about open source to begin with. But yeah, let's kind of, take a look at our agenda today.
First, we are going to confront the elephant in the room, the new cloud lock-in. We will examine how the current AI arms race is silently trapping engineering organizations into proprietary vendor ecosystems, and why relying on a single provider is a massive risk to our scalability, security, and bottom line. Second, we'll introduce the antidote, DIO, or Distributed Intelligence Orchestration. We will walk through the architectural paradigm shift required to decouple the intelligence layer from the business logics. We'll talk about building systems that are adaptive, model agnostic, and resilient. Then we will spend most of the session in the hands-on lab. We will work with the open source DIO core framework to get both policy-based and FDE-based dynamic routing working in action. Finally, we will leave some time for Q&A. Our goal today is simple. By the end of the session, everyone will take away the solution to solve your AI vendor management and maintenance challenge. Ready to move forward?
And for this one specifically, I also added some mobile specific considerations and a Kotlin kind of starter script that we can take a look at the end.
Let's look at the reality of enterprise AI today. We are currently trapped in what I call the false binary. Right now, when engineering leaders architect AI applications, they are forced to choose between two fundamentally flawed paths. Option A is the cloud wrapper. You take a frontier model, API, wrap it in your application, and you move fast. It is incredibly quick to prototype. But the moment you hit enterprise production, the cracks show. You suffer from leaky data, surrendering your data's sovereignty to third-party providers. You experience silent regressions. The provider updates their model behind the scenes, and your perfectly tuned application suddenly breaks without warning. And of course, your costs become wildly unpredictable as usage scales. So companies swing to option B, pure on-premise. They bring open source models in-house. It is secure. You own your data, but the operational trade-offs are brutal. It introduces massive infrastructure complexity, a heavy maintenance burden, and your capabilities constantly lag behind the bleeding edge frontier models. The industry treats this as an either slash or decision, fast or secure, capability or control. This is the trap. The reality is that true enterprise-grade production requires both. We need the speed and reasoning capabilities of the cloud, fused with the absolute security and governance of on-prem. So, what does this false binary actually cost the industry when we try to force fit these solutions? Let's look at the numbers on the next slide. We are looking at four massive shifts that define our current code red reality. On the top left, the enterprise spend explosion. In a span of just 6 months, enterprise spend on LLM API skyrocketed from $3.5 billion to $8.4 billion. But here's the paradox we have to call out. Why did our spending more than double while the actual cost of the underlying models dropped by 280 times? The answer lies on the right, the market share battle and the switching phenomenon. The AI landscape is incredibly volatile. We saw Anthropic overtake OpenAI in 2025, capturing 32% of the market. Because these models are advancing so quickly, builders are not staying loyal. We are seeing a phenomenon where engineering teams migrate en masse in a matter of weeks to chase the state of the art, moving from GPT-5 to Claude Opus, and now to Gemini 3. But this switching comes at a massive cost. Every time a new frontier model drops, teams are forced to rip out their old static cloud wrappers and rewrite their integrations. They are bleeding engineering hours just to avoid falling behind. This friction is exactly why the gateway and orchestration market, shown in the bottom left, is projecting a massive 45.7% compound annual growth rate. It is growing faster than the models themselves because the industry is desperately trying to abstract away this vendor churn. But as we will see on the next slide, simply slapping a basic gateway in front of your models does not solve the underlying complexity of what we are dealing with. We are looking at four massive shifts. So if the market is volatile and expensive, what is the alternative? When I first published this article on Medium last November, the landscape was quite different. Open models were trailing behind. But let's look at the hard data from just this week, February 12, 2026. This is the updated Legal Bench leaderboard, testing complex legal reasoning. On the left, you have the closed source giants. Gemini 3 Pro has retaken the crown at 87% accuracy. Powerful, but expensive, costing up to $12 per million output tokens. Now, look to the right at the open weights models. The rumors were true. GLM5 has landed, and it is hitting over 84% accuracy. The gap between the absolute best proprietary model and the models you can run on your own infrastructure is now barely 2%, with less than half the cost. And look further down at Qwen 3. It is barely 20 cents on the dollar compared to the giants. This is the turning point. Good enough is now elite, and it's available without the cloud lock-in. Also, notice the irony. On the previous slide, we saw the market flocking to Anthropic. But look at the leaderboard today. Gemini is back on top. By the time a company finishes migrating to Anthropic, they're already behind. This is why we don't pick one winner. We need a system that adapts to any winner. We need distributed intelligence orchestration, DIO.
And I think, to reinforce on the previous slide, if we look at the current benchmark, I use Legal Bench because it's actually a little bit more dynamic than the kind of general one. And also it's what a lot of our clients, which are kind of, lawyers look at, is that it's actually more kind of the gaps are more closed up. If we look at Qwen, it's kind of, overpassing GLM5, and it's already kind of crawling its way in the overall board right after the kind of the cloud opus. So I think, it's already really clear that it's going to be a really dynamic space, and if someone is kind of keeping an eye on Hugging Face or things like that, I think there are now like over 10,000 of different models, even for kind of a static gateway providers like LLM or Open Router, there are like thousands of models available. I think that's a problem that we're trying to solve here.
DIO is a federated architecture that fundamentally decouples your application logic from model inference. In the current market, the majority of software has hard-coded dependency on one or several vendors. In the DIO world, applications handle the business logic and stop worrying about vendor management. We stop building GPT wrappers and start building resilient intelligence platforms. And what does that platform actually look like? Let's look at the blueprint. Most AI applications today pipe directly from business logic straight into a frontier model at layer 5. That direct connection leads to many struggles in production I outlined in my blog articles. It's brittle, it's expensive, and from a compliance standpoint, it's highly insecure. Production solutions need robustness. We have to fundamentally decouple the application logic from the model inference. That's what the DIO framework does. We insert a brain into the middle of the stack to act as a unified orchestration and control plane. Notice layer 2 here, the Federated Decision Engine, or FDE. This is where all the complexity of model selection is happening. It evaluates every single request against your production constraints. We will look at the set of algorithms in the open source version, whereas our premium version has a constantly evolving mechanism, just like the world of AI. For production use cases, the telemetry and observability at layer 6 is essential, as it tracks cost attribution and distributed traces across the entire system. And this keeps you well informed as well as worry-free from AI vendor management. Let's look at a conceptual example of how a request flows through the architecture. Imagine a user asks a system to generate patent claims for a distributed training system. First, consider the feature extraction layer. In this embodiment, the system doesn't just treat the input as text strings. It analyzes the state of the request, potentially extracting a vector that identifies it as highly technical and legal. It's characterizing the intent. Next comes the model capability tensor. This represents the system's current knowledge of available models. For instance, the system might flag a newer model, like Gemini 3, with high epistemic uncertainty. This simply means the system detects a gap in its own confidence regarding that model's performance on this specific topic. Then the user preference is applied. This is where the governance logic is applied, whether the priority is strict cost control, lowest latency, or maximum accuracy. Finally, leads to the decision. Rather than a static rule, the system might use a probabilistic method like Thompson sampling to balance the trade-off. It might decide to explore that uncertain model to gain new information or exploit a known winner. This isn't just routing, it is continuous learning. The outcome of this interaction updates the system's beliefs, allowing the architecture to continuously self-optimize without human intervention. Let's look at, so what exactly is the Federated Decision Engine, or FDE? Think of the FDE as an intelligent arbiter. It sits between users and the models, evaluating every single request against a set of governance rules. Examples of primary dimensions. Privacy routing. I always advise our clients to put this as a must-have. Many clients now actually request a dedicated audit as all sorts of private data leaking are being diagnosed in their existing systems. As for DIO, if the engine detects sensitive information like a social security number or confidential client data, it instantly forces that request to a local on-premise model. It never touches the public cloud. Cost optimization. The engine asks, do I really need a Ferrari to pick up groceries? If the task is a simple classification or summarization, it will try to route it to a smaller, cheaper model like Llama 3 or Gemini Flash. Complexity analysis. If the request requires deep legal reasoning or complex coding, the engine recognizes that difficulty and leans towards routing it to a frontier model like Gemini 3 Pro or GPT-5, prioritizing quality and depth. And the real magic isn't just setting these rules, it's how the system learns to apply them dynamically. I'm happy to share some mechanisms that make this possible. Now, let's open the black box of the Federated Decision Engine. Traditional routers rely on static logic. The FDE treats every routing decision as a probabilistic optimization problem. It operates in multiple distinct stages. State evaluation. When a request comes in, we don't just look at the text. We look at the state space. We calculate the feature estimation. This extracts the DNA of the prompt. Is it creative? Is it code? Is it adversarial? We combine that with the model capability tensor. This is where we separate aleatoric uncertainty, random noise, from epistemic uncertainty, what we simply don't know yet. Then the decision process. We project these values onto a probabilistic Pareto frontier. This allows us to mathematically dominate suboptimal models. We then leverage a set of algorithms, for example, Thompson sampling, to choose the best path, balancing exploitation using the best known model with exploration, testing a new model like DeepSeek or Llama 4. Execution is easy now. The request is routed to the optimal provider, whether that's cloud, on-prem, or a custom model. Finally, and most importantly, the learning loop. Every outcome feeds back into the system. If a model starts drifting or failing, we update accordingly. The system is always improving, and we are actually utilizing more and more artificial intelligence in this evolution so that our clients can sit back and relax. There are a lot more on DIO and other technical blueprints on my blog. Now let's get to the lab and get our hands dirty. We are going to build on top of the DIO core starter kit. By the end of this session, we will each have a working DIO running that is fail-safe, privacy-aware, and cost-effective.
So yeah, originally this is designed to be a workshop, but I think, we'll go through the code base together. And I'll leave some time if people want to kind of install and play around with it. It should be really intuitive and easy to set up, and I would love to have kind of feedback from the community. Yeah, let's get into it. Yeah, I understand that people have our own kind of, pace. So want to make sure that no one gets left behind. So please, if you want to kind of, join the workshop or you want to get some support or generally ask questions, keep in touch. Just use this kind of, QR code to join our Slack channel. My colleague, Tony is going to be in the channel answering questions in case I cannot get to them during this talk. Hey Tony, yeah, I can see him in the meeting now as well. I'll give everyone kind of some time to join, and we'll also be posting the materials and the kind of other related stuff there after the session as well. If you have questions, you can drop a screenshot or whatever code snippet. So yeah, hey Tony, he's waving his hand. Okay.
Quick environment check. Couple things first. You should have your DIO core installed. If you haven't cloned the repo yet, the URL is on the screen. You will need Python 3.8 or higher and the DIO core package installed. If you want to use the actual cloud API for this session, put your Gemini, OpenAI, or Anthropic key in your .env file now to see real production responses. If you don't have keys, don't worry. This lab mocks the providers so you can still verify the routing logic. Third is optional local compute. If you already have Llama installed with Llama 3, great. We can do full local routing. If not, don't worry about installing it now. We can simulate the local parts or use the cloud fallback. Finally, let's get the code. Please run the commands at the bottom of the screen. Clone the repo from the GitHub link. CD into the directory. Install requirements to grab the dependencies. I would recommend using a virtual environment as it is general good practice. I'll give everyone a minute to get those commands running.
And I actually, because I use my kind of local private host models so much, so I actually added a web host option in the providers, as we'll see later when we're scrolling through the kind of project structure. So if that's something that you use as well, it's just as simple as adding your base URL. Of course, I think it also depends on how you're configuring your kind of network host, but I use I think the one I'm using is a tail scale like mesh network that I just have another kind of script running on my host machine. If anyone's interested in setting that up, because it's a question that I get a lot in other talks, let me know as well, and I'm happy to kind of, talk about that. But does anyone need a minute? If no, I'll just proceed. So this is kind of, a quick tour on the repository or the project structure. I'm assuming that you already cloned it, or you can also just browse through the kind of GitHub repo to take a look. Is it's a really modularized kind of code base. I mean, I pretty much designed the modularity at Messenger while I was working at Meta, so it's always a principle that we will adopt. So as you can see, the routing logic is completely sort of decoupled from the models it routes to, and we also for components or modules like API, it's optional. If you don't need it, you can just use the core kind of DIO core library. But if you do, you want to add a flag to make sure that you install that as well. And basically, I mean, it's every provider is swappable without touching a single line of business logic. And if we walk through it layer by layer, the core engine, as you can see, is the agentic core. This is sort of the brain of DIO. Everything routing related lives here. Start with kind of dio.python. This is the public API. This is probably the class most user, not the class, I guess. What does Python call it? It's still a class, I guess. Sorry, I came from the Java era, but this is the place where most users will touch. There are things that's kind of like add provider, add policy, route, and we'll go into examples on some common ways to integrate with it in a bit. And then there's the FDE. It's, as we talk about, Federated Decision Engine. This is where all the kind of the routing or FDE related routing decisions happen, because we do have policy-based routing as well, as we will see in a little bit. In the open source version, it scores every available providers on 4 axes simultaneously. There's privacy, there's capability, there's cost and latency. And it'll kind of calculate and picks the highest score, like a weighted decision. I've actually put a lot of thoughts into how we can balance the effectiveness and accuracy without, all the really complex reinforced learning and ML algorithms in our premium version, so that developers can quickly bootstrap with something that's lightweight, and experience the benefits before or even without proceeding with a license if it's not for commercial use. And then we have the router, the seats on top of the FDE. It's basically kind of, what other gateways doing. It's sort of static routing. But it takes, in our case, it takes the scores and applies the hard constraints like require local or maximum cost before kind of making the final routing. Then there's
now, if we run the quick start script.
Sorry, I shouldn't have clicked on that. And then we have the PII detector. You see in this open source version, it's like, 30 lines of, I think, regex mapping, but it covers already kind of SSN, credit cards, email addresses, phone numbers, the the kind of core set of PII information. In reality, though, if you want to use it on a production app, I think you need some kind of network call with a third-party library or other customized logic. But it's something that I think pretty, again, lightweight to get bootstrapped if you just want to try out some ideas. And then we have the provider. We define the provider is sort of just like, a general interface for kind of plug in all the different providers. For this open source version, we have just the common major cloud providers, GPT, Gemini Cloud, and Llama. And like I said, the web host, just because I used it a lot when I'm kind of, doing my internal testing, and I figure it'd be convenient to add since it's just a basic REST kind of HTTP call. And you pass kind of, a model name, and the registry will fill in a lot of the information kind of automatically, as you'll see later. Then I think, the server, I noticed that I was talking about API kind of interchangeably for the DIO API and kind of the server API, but yeah, the one that I was talking about that can be installed as a module is the server API. The DIO API is going to just be in the core no matter what. This is sort of what I put together for this kind of meetup specifically, because I figure that mobile developers probably won't be using this inside an Android app. If I were to imagine, you probably have some kind of server logics that can use DIO or having it as a separate service somewhere in your kind of code base. This is just a kind of a REST API. I think now we have 3 endpoints. There's the health endpoint, there's the provider's endpoint, and there's the infer endpoints, as we'll see in our examples when we dive in the code base. And for the open source version, we include like a reason. We also include a bunch of information in terms of like scoring, like why this model is chosen, in case you want to kind of improve it yourself, add custom logics. I think it's just more informative. And then we're at the models. This defines the request schema in kind of OpenAI message format. I think this is the most widely used one. In fact, we're going to probably include providers like open routers and like LLM in the open source version as well, which also use the OpenAI message format, because I think it's the earliest and more widely used. And in that case, if you're also using kind of, like LLM or open router, you just kind of, you probably will just need minimum change in terms of your API logics. And then there's the device context. This is the translation kind of layer for mobile. It takes raw Android or iOS device state like battery levels, connectivity, and convert it into FDE routing constraints. The app doesn't need to know anything about the DIO's internals. I think this is something that I learned when I was building Android in the early days, whereas we gradually shift towards to make the client as dumb as possible. And I personally love to have kind of people who have mobile experience in terms of building more full stack solution or backend solutions, because I think a lot of time that perspective is overlooked or comes in the day two, which often can be too late. So if any of you have any ideas on how we can make things more mobile friendly, please let me know. I would love to know more about how things are in the modern kind of, application world. Um, and then I think circle back to the project base, the provider we'll see how they're used, but it's pretty standard as your kind of normal providers in terms of LLM vendor. And then we have policies. So right now there are two defined policies. One is the PII-based routing policy. It doesn't have to be PII. It could be anything that your business considered as privacy. And there's also a fallback for stability or reliability of apps. This happens when one provider time out or throw an error, then you can set it up to automatically rerouting to the next best option. Again, I think every production app or solution should have something like this. The next is the data layers. This is something that I added after a couple conferences that people wanting to have more, I think, to have the open source version more usable in their day-to-day, instead of they have to hard code the capability every time. So this is, right now it's using the LM-sys ELO capability for the open source. If you are interested in adding more on specific area or having more dynamic kind of, scoring, or even have your customized scorings, we should talk. And right now, the open source one, if you download it from GitHub already, it doesn't have the cost registry yet. I was going to commit it, but I guess I'll do it later today. Then there's the tests. I think right now we have 50 tests covering kind of fast API integration, the FDE, end-to-end PII, like from integration to unit test, basically. All of this run in our GitHub Actions. And I think you should be fine as long as you have Python 3.10 or more. And let's see, the next thing is examples where we'll be spend a lot of time on for the rest of this talk or workshop. We'll kind of, dive in, but I'll give a brief overview. The quick start is really more on the policy-based kind of, use case, which I imagine for people who are building really simple ideas or just really care specific area, for example, privacy over everything, which it's not uncommon in a lot of corporate clients. This is a good place to start. It's the easiest to set up, and it's just like routing based on strict policies. Then there's the cloud and hybrid and private models. The hybrid models were sort of what we originally have that has a mixed use of cloud and local, like 5 basically providers at the same time. And it's not hard to guess that you would probably try to use the frontier cloud models for the more complex queries where you don't care that much about privacy, if at all. But then I quickly realized that there are companies, even some of my friends at the big company like Meta or Google, that are still using one provider, meaning that they depend on Gemini or Claude majority of the times. And we were having this discussion on whether a DIO is needed. And I think my answer is yes, because even Google has like probably 10 different models nowadays, right? And there's also the Gemini Nano that's living on a lot of the Android devices. So I built these two examples to kind of, demonstrate that you would need, you would still benefit from DIO even if you're mainly using one provider. So let's see. And there's the Python kind of, those are just the basic ones. But I think one thing that's missing here is the .env file. There's a .env.example file in the GitHub repository where you can comment out the .example and add your API keys, your kind of, web host URLs and things like that to make sure that you can use the real providers instead of the mock ones. So I guess we can just go ahead and open the quick start Python right now. And it's here.
This is an example of how to plug in the business logic and let DIO handle the interaction with intelligence models. We'll start with the policy-based approach running mock models to get familiar with the syntax. First, we import DIO and create two providers, a cloud provider and a local provider. Notice the local provider has a lower cost for both input and output. This will matter for our cost optimization later. We initialize DIO and add both providers. Now let's add our first policy, privacy protection. We write a simple function that checks if the prompt contains PII using the built-in PII detector. If PII is found, we return restricted, otherwise public. We add this policy with strict enforcement or in some, meaning it must be satisfied, no exceptions. Restricted automatically routes to local providers for data sovereignty. Public automatically routes to the cloud for best capability. This is convention over configuration. Common patterns just work. Now, if we run the quick start script, we'll see that DIO detects the PII and routes to our local provider when we route a prompt with a social security number. On the other hand, when we ask what is Python, no PII detected, it routes to the cloud provider. Tony just posted the sample output in the Slack channel. As you can see, privacy is enforced automatically. Let's move to cost optimization.
I'll pause here a little bit in case there are questions. I cannot really see people's hands because it's so small, but great, we'll move forward.
There are many things we can do with policies. We can create a dummy policy that classifies queries as simple or complex based on keywords. If the prompt contains what is, define, or similar keywords, it's simple, otherwise complex. We add this as an advisory policy, meaning it can be overridden by strict policies like our privacy rule. Now we need to map our custom classifications. Simple goes to the cost-effective local provider. Complex goes to the expensive but capable cloud provider. In practice, we can use an on-prem model on top to sort this out.
Yeah, again, this kind of, open source library is really for you to kind of, be able to configure and put in your custom logics. But our premium version would have a more generalized definition and algorithm in terms of what is complex and what is simple.
Now both policies work together. Simple queries route to cost-effective local. Complex queries route to capable cloud. But look at example 5. What if a query has both PII and complexity? That's right. The strict privacy policy wins. PII always goes local, regardless of complexity. This is policy composition, multiple policies working together with clear precedence rules.
Again, you can add your own policies. I think in practice, we see a lot of clients saying that a certain kind of department or certain type of business queries would go to kind of a specific type of providers. And I think, there's also context management that you can add into it to help make it more useful and applicable for your business case. And then we also, I think this is a request from some of the folks from the community that they want to see how the cost is calculated. So there's a more detailed breakdown logic on how the kind of cost is calculated in the open source one. If you use AI a lot in your practice, I think you'll see that right now it's getting more complicated in terms of there's also the cached kind of request cost on top of it, and there's also image cost, and which goes into a different type of calculation. And if you run the script, then you see the example 6 would see a lot of, would kind of show you how the detailed breakdown is available. This is something that, if you want to use in your dashboard or visual data visualization, that's pretty handy.
Next thing we need to talk about is production reliability. In real deployments, API fails, rate limits, system down, network breaks. The list go on and on. DIO supports automatic failover. We can add a backup cloud provider and configure it as a fallback for the primary. Now, when we route a query, if the primary provider fails, DIO automatically tries the backup. The response tells you whether failover was used. This is production-grade resilience built in. Again, please find the output in our Slack channel and ask any questions you have there. That was an overview of policy-based approach where explicit rules are defined. Now let's look at the alternative, Federated Decision Engine, or FDE, which I would recommend for a more dynamic use case. Instead of writing rules, we tell DIO our priorities using weights. DIO automatically scores providers and picks the best match. This is the production-grade approach for complex multi-objective optimization. And our ML experts can tailor the parameters and weight for our clients. If you haven't done so already, set your API keys in the .env file.
I'm gonna give some time if folks are trying to set things up for their development. Great. If there's no question, we'll kind of dive into how the FDE works.
Here, you can change the specific model to what you want. For example, GPT-5 instead of 4. And update the pricing if you want, since corporate clients often have enterprise pricing. Here's how we initialize FDE. We set use FDE equals true and provide weights for 4 dimensions. Privacy is 40%, our top priority.
And here, I think I changed it a little bit to demonstrate some of the kind of, the algorithms that we improved. So the cost is 0.2 and the capability is 0.35, and the latency is kind of 0.05. And notice that we also set privacy providers, which we're using Llama 3 here, to make sure that we have a fallback for the PII situations. Think of it as a kind of a hard rule that runs or overrides the FDE scoring. It's pretty intuitive that if you have sensitive information, you would go to local kind of period. And then FDE would optimize everything else.
So how does FDE actually work? For each non-PII query, DIO calculates a score for every provider. Score equals privacy times 0.4 plus cost times 0.25 plus capability times 0.25 plus latency times 0.1. For what is Python? Maybe Llama 3 scores highest because it's cost effective and fast enough. For explain cap theorem, maybe Gemini scores highest because capability matters more. DIO automatically picks the best match based on your weights. You don't write any classification logic.
And I think an interesting thing is, as I was testing with my local host the other day, I was using the Llama 3 8B. I was setting it up as a kind of a lower capability model compared to the cloud ones. But I was really surprised that the kind of CAP or CAP theorem was explained really well. It's pretty much comparable to a lot of the frontier models. So I think it makes a even stronger case that we should be designed for a multi-model kind of world in this current AI era. And this is why that we need some kind of dynamic routing to get the best out of our money, our time, and our business use case. And this is the result of kind of the exercise 1 in the hybrid models.python in the examples. Notice that there's the warning that we set up saying that the current capability score is basically auto-loaded from a static kind of static data file that we have in the open source. In the open source library, you can either port in your own data for capabilities and costs and things like that, or you can kind of talk to us in terms of making it more useful. And then here are the kind of the output, for example, for examples, right? It's for sensitive privacy data. We would always go to kind of the local ones, whereas for simple question we would go to the local one as well because it's cheaper, and we actually cap the capability in our implementation to be like, if it's a simple query, it should be, I think the number was either 0.6 or 0.7 to be the highest, because we don't need the additional capability for simple questions. And then for the complex reasoning, right, we're going with the cloud models. So this is the exercise 1. And then for exercise 2, it's a sort of like, if you uncomment this code in your IDE, you see that tuning kind of the weights would result in different selection of models. Obviously, right now this is more cost driven, which is also, I think, probably the second biggest use case for our clients that we're talking to, especially for startups that are using a lot of AIs, but they are trying to make sure that they're budget aware. So you can train it up as much as you want to, and you see just like, how it'll affect the result. Yeah, I think this is probably an outdated example. Tony will post a more updated one in the Slack chat. But any questions before I move forward? Okay, I think right now we're probably, let me see, I think we can jump in our code base a little bit to see some of the, yeah, forgive me, I have some interesting kind of, working repository right now, but we'll look at the ones that are not touched or not affected by the changes right now. For example, I think, we can take a look at how the model capabilities is constructed. This is a little different from the current GitHub version because it's already including all the costs and stuff. Because we want, again, we're trying to make this open source version as useful as it can be for every developer without adding too much complexity or dependency on our kind of dynamic premium version. And this is where you can come in and add a specific kind of, model that you're using that's not included here, or this could be something that you try to kind of bring in a dynamic database in terms of, the model benchmarking and things like that. And then the next example I want to talk about is this private models, the Python. It's very interesting, right? Like, now we can pretty much rely on private or open-weighted models for a lot of the tasks that are happening in the application of AI world. So you can see that here, I pretty much, I have two kind of, models that are private. One is the Llama 3 latest. I think this is the one that's 2 years or even 3 years old now, like one of the really early Llama ones. That is only 8B. And there's also the kind of GPT-OSS 20B as the more frontier model here. I have kind of the cost per token here, but really is pretty much near to zero if you're self-hosting it. If you are using OpenRouter or things like that, it's another story, but that can be configured for your specific use case. And then you can see how we are kind of defining the FDE here as well with the weight. And here we don't really need a local model for kind of the privacy because everything is private already. And then the test case here is what is Python? Actually, I think I have a lot more. Oh yeah, actually there are, I think, three things, right? Like, what is Python, define machine learning, and cap theorem in distributed system, like, basically a really complex one from how we define it. And you see that when you run this, the first two will go to the Llama 3 latest, the 8B model, whereas the last one will go to the GPT-OSS.
Hey, Snow, real quick.
Mhm.
Sorry to interrupt. Are you sharing, because we're seeing your slides, are you showing some code?
Oh, I'm sorry. I thought wait, I'm talking about this for 5 minutes and then, wait,
It's okay, we all remember.
I thought I'm sharing my entire desktop. Well, lucky that you didn't see my DoorDash order. when I was
now
switching, yeah. Okay. Do you want me to quickly go over what I was talking about again? But yeah, well, no, that's
yeah,
not
if you want to quickly cover it, we have about 20 minutes.
Yeah. Wait. I have where was it? Oh, here. Yeah. This is sort of the first file that I was talking about. This is where, if you want to play with the open source version that you can use dynamic loaded scoring, you can kind of, enrich the capability to not only the general capability, but also maybe text, image, audio, and also cost. This is something that we put from the kind of, the public API, but then I believe if you use different gateway, they would have different pricing. That's also something that you can customize, or you can kind of, get out of, our kind of dynamic version. And then I was talking about this kind of two examples here, where, remember a couple slides ago, I was saying that I've been debating with my friends on whether they need something like this for even if they're only using Gemini or Cloud, right? And this is the private one that I'm talking about, right? Even if you're just using kind of, Llama, does it make sense for you to have something like this? Or if you're just using kind of Gemini, which the structure of this example is very similar in terms of yeah, I can have just two two Gemini kind of, models, or two, here I have two OpenAI models that it'll still make a difference when you kind of give them different questions or different problems to solve. You get kind of, higher quality kind of, result when it's needed, but you'll save money when you don't need kind of the frontier models, calculation, and reasonings. And I think we can wrap up on examples here a little bit, and then we'll leave some questions, Q&A time at the end. So going back to my slide, this is basically, let's see. I think I sort of kind of, touched on this a little bit, that there are a lot more ways to utilize kind of DIO, especially how we're evolving with the development of AI industry, that this is something that I would definitely not be thinking about like 8 months ago, but now this is becoming one of our most popular project that even started to get the open source community folks to wanting to contribute. We believe strongly in open source because I think, developers need transparency at the execution layer, and I think it's the best way to build kind of a prod infra layer for this kind of evolving environment. Therefore, I think, DIO Core, the open source version, gives a highly customizable solution that fits basic development need straight out of the box. And on the other hand, right, we know what happens on day 2. The prices change, API migrates, big cloud players have latency spikes all the time, and they change their policy, and they leak data, right? A new kind of, regulation would drop in EU, and that'll change everything that we've kind of, implemented so far. if any of that sounds applicable, you should come talk to me because that's something that we happily handle for clients. And and then we also have lab benchmarks and things like that. That's again something that you can implement yourself out of the kind of the open source version if for non-commercial usage as well. And this kind of brings us to who we are. I'm gonna do a quick kind of advertisement for Agentic, which is basically my company. We were born in the Valley out of decades of experience building the softwares that affected billions of people. And our mission is to kind of build for the world. We don't just deliver software, we go above and beyond. And we kind of have this FDE approach, if any of you is familiar with Palantir, that we have our core kind of infra and technologies. All of these things that I'm talking about already have a patent number, so we're just going through the process of patenting everything. And we understand that every business is unique. So we excel at delivering tailored, high-performance solutions with the speed of startup and at the rigor of a tech giant. Our clients are generally impressed of how we kind of take forward deployed engineering to the next level. And we're always kind of steps ahead of the industries. Again, the DIO was actually a project that's already 6 months old before kind of this. I think even right now when I'm at conference, this is the only solution that takes care of this sort of problems. And we also have kind of pending Women Business Enterprise Council certification and minority-owned leadership. We help our clients meet kind of strategic ESG goals and give back to the community. Another thing is we're actually opening up our first set of hackathons right now. So if you're interested, if you're eager to learn and you're not afraid to take on kind of all sorts of challenges with tons of uncertainties, reach me out. I think we can try to take the conversation forward. That's all I have. There's the website where you can kind of sign up on our contact list. We have newsletters on all the things happening, especially in building enterprise AI solutions, and also the talks materials and the starter kit and things like that. But with that said, I think we have like 10 minutes, right? We can ask questions or we can talk about, the trends in AI or, what's happening in the Android community. Yeah, I'll just open up the kind of, the discussion now.
Okay, we'll start in the room. We have a question here, but you can talk from here. This mic is
okay. So nice to meet you today. I see you're having fun in this world. My name is Joseph White. I'm with Velocity. I have one question. You're identifying a multifaceted query that runs into your system to help route where it ought to go. I was wondering to be able to identify how complex something is or how simple, or whether it has different types of proprietary information from personal information to others. Is that something that one defines inside the Python, or do you use the model itself to try to understand that capability?
Yeah, I think the question is how we are kind of handling the kind of private information, I guess, definition, right? Or just like the algorithm to detect private information, right?
Right, yes. How do you determine that? Is that something that's
Yeah.
programmatic, or do you use a model itself to help identify those facets?
Yeah, that's a great question. As you can imagine, we definitely use model, not one model, but like everything we do, it's a lot of models, and it's a combination of both. There's programmatically defined things like like regex is really easy. It covers a lot of the kind of the basic cases, but then there are also things that I think worth getting an AI model to look at it, or more precisely, AI agents. Actually, for some clients, we use multiple AI agents because they have specific regulations that they're facing, and you can imagine things like one kind of HIPAA agent, one what's it called, GDPR agent, and then I think it's not so that they have a precise understanding of what they're looking at without kind of getting their context polluted. I think another kind of benefit of this, it's sort of like modularized. We haven't tried that yet, but I think it's gonna be easy when we're trying to kind of port them to different clients and kind of in different ecosystems. Does that answer your question?
Yes. Yes, that was very good. It struck me that that's clearly a major extensible area that one could spend a lifetime doing in addition.
Exactly. I think EU is creating a lot of opportunities in terms of kind of regulation and like the privacy sort of things. And it's gonna be well, I mean, I think it's already $1 billion industry, but it's gonna be bigger than it is today for sure.
I have one follow-up.
Go ahead. Yeah.
I have another question, but I don't want to get in front of someone else.
I mean, I cannot see what's happening in the room because it's so small. So I guess our host will help.
Yeah, I'm watching DC. Does New York, Madonna, does New York have any questions? I just want to make sure there's equal opportunity.
No, we don't have any question currently.
Okay, so we'll stay. Go ahead.
So your routing side, where to go, sounds very interesting. Certainly as you take the different complexities and elements. Have you also dealt with some of the processes that Lovable talked about having to rewrite their system with, where they're dealing with external models, being able to deal with which ones of these are getting close to my caps and how do I move from one spot to another because I've got to handle that. I don't know if you saw Lovable's recent paper about the re-engineering of their routing system, all into the back end or not.
Let me try to see if I understand the question. You're talking about Lovable is routing their kind of agents or models to what? To backend?
So what Lovable is doing is a lot of their work. They aim information into Gemini's AI Vertex or Claude into Deep Area or OpenAI, all of the different cloud providers that they've got agreements on, but as they get to near a limit, they need to move somewhere else and they need to figure, well, when do I need to move rather than my work starting? And they had talked in a recent article about how they re-engineered their way from how they thought things were. I just wondered whether you were dealing with that side when you do move things off local sites to other providers, whether that's an area that you've worked with. You may need to go find out what I'm talking about to answer, but.
Yeah, I would love to check out that article, but I think what we are dealing with, or at least our clients' challenges right now, is sort of from cloud to kind of private. Right now, I see that as a trend in the enterprise area. I don't know if you've kind of been following the legal side of news because a lot of our kind of clients or products are in that area. Is that recently the court ordered So I think, in general, cloud or the cloud providers have user agreements saying that they, for enterprise clients, they would not use their data for training or expose their data in any way. But recently, there are a lot of cases that court basically ordered that to be kind of, illegal, and their data are still kind of exposed as part of the evidence to the public. So that's why we're kind of, we're seeing our clients panicking about that they're breaking their client attorney privilege, and they're trying to take away everything that they have from the cloud. Yeah, again, I'd love to see that article or take this discussion offline, as I think I'll have more context on that story. But I guess Lovable is probably working with consumers primarily, right? Which may be a different set of challenges.
Right. So where does DIO interface? You may have interactions that have a large amount of company data that I might want to set up, and then being able to ask a question about the data, and the model would need to have some of that information, have access to that information. Where does DIO interface? I mean, I see how it would interface if I were a chatbot, or a high-end knowledge, interface coming through. But what do you do if you've got to have a lot of background company-specific data on a model?
Right.
To make questions about that.
Yeah, so the question is where are the kind of or how is the interface of DIO like? Right now, the open source one doesn't have kind of a user interface, whereas the enterprise one does have visualizations. There are basic ones that, yeah, actually it would be nice if next time I'll just show some of our kind of enterprise version UI to help people understand better. But yeah, it's just like dashboards like you would imagine. There are things like how many queries that were routed where, and there's also cost saving projections. Our customers may have specific goals that they're trying to meet, and sometimes they might care about kind of, for example, legal firms, they care about quality drastically. So that might be mapped to their kind of specific benchmarking. Yeah, I don't know if the community is really kind of, interested in something like that, we might think about adding something to the open source one as well.
Well, it's very interesting. You've got a wide frontier that you're bringing value to.
Yeah, because
yeah, so that's good. You bring value one place, and I'm sure people only want 100 times more, right?
Yeah, because imagine how a lot of our clients are not really technical company. They have IT team, but they don't have kind of engineer. Then the decision makers would like to see something that they can read without having to use the CLI all the time. So
it makes a lot of sense. I agree.
All right, awesome. Thank you for the great talk. So just wanna give a round.
Thank you. Yeah, I'm really glad to be here. Yeah, I would love to see people in person sometimes. Maybe next time when I'm kind of traveling to New York.
Yeah, perfect. Yeah, stay in touch, and well, if you're in New York or in DC, either one, reach out and we can set something up. Awesome. Thanks again, and I think we'll hand it over to Karen, who's also online. I posted the intro, so Snow, whenever you want to stop sharing, and thank you again. So just in the interest of time, I will just directly hand it over to Karen. I think everyone has seen the bio and the intro. He's going to be talking about SQLite and his experience in Android. So whenever you're ready, you can start sharing.
Oops. Hey guys, do you hear me? Can you hear me properly?
Yes, we can hear you.
All right. I don't know why you see my screen. You should be seeing.
We see your desktop.
You see my desktop.
Yes.
Yeah, I have not used Zoom on this machine, so I'm just trying to get things set up once.
No worries.
Right. I'm also going to start my speaker notes. Do you see the slides now?
Yeah, we see the slides.
You see the slides. Okay, great. All right. Hi everyone. I'm Kiran, and I'm a mobile developer at Somnox. We have quite a few slides, so I'm going to actually start going very quickly. Throughout my career, right, whenever I have had to use SQL in any sort of application, mobile, backend, I have typically done it. I have typically tried to do it as much in the application code as possible. So that means I've tried to use SQL only in the leaf queries, and then I've tried to combine them in the application code. But in this talk, I'm going to try to convince you that that's not the best idea most of the time, and that you should instead try to use SQL to the extent possible and only fall back to using your application code in certain cases. Just a note, the examples in this presentation are going to be with Kotlin, SQLite, and SQLite as a library, but much of these applies to any programming language or any SQL library. But let's also talk about the motivation, right? Like why do I make this claim that you should try to use SQL as much as possible? The first thing that actually comes to mind is performance. But in our case, in the Somnox app, we'll see some examples of this. But in our case, in Somnox app, it's not even about performance because we hardly have handful, maybe like 10 rows in our database. So performance is not the primary motivator. It was the first reason actually is data integrity, because if you have your queries and your constraints as close as possible to the data, then the chances of the data integrity being maintained are higher. The next reason is that if you use SQL, then your queries do not depend on what library you use. Whether you use GRDB on Swift or you use Room in Kotlin or use SQLite, the queries remain the same. And the next is, this is kind of related to the previous previous point. And that is that your skills transfer to other domains. Like this has been actually my experience. The SQL manipulation that I learned during my mobile app development, I was able to use some of that also while developing for the backend with Postgres and things like that. So let's start with some code samples. Right, this is kind of like a baseline schema change that you'll see when you're using SQL, right? That is that you have a table and you need to add a column to the table. So let's start with the simple, right? And then we move to more complex topics. And this column has a default value, okay? Now, what if we wanted to set a conditional value for this column? Let's say if this table was about devices, right? And if you wanted to add a constraint that if it's a first gen device, then you set this column to true, otherwise you set it to false. Like, can you do this in SQL? Well, it turns out in SQLite, you cannot. So you cannot you cannot add an expression after this default clause. So then you might try to fall back and do this in Kotlin, right? And this is you have one query that gets all the rows from your database. That's the get rows from DB clause. And then you iterate through that, and then you get this Boolean. If it's a first gen, you set this value to true. But there's actually a better way. You can actually do this in Kotlin. You can actually do this in SQL. And this is using like the update query. And then you have this case expression. This is a simple case, but you could have more complex cases in this. One thing to note is that this update statement, this is an update statement. This is not part of an alter table statement. So you are actually, this update statement follows the alter table statement. So in this way, in this case, this is kind of transactionally equivalent to the Kotlin example. Sorry, I'm going to turn on one more light. Yeah. So in this way, this is transactionally equivalent to the Kotlin example. So let's go. Let's move on to some actual examples from the Somnox app. For those of you who don't know, I don't know if you can see this, but the Somnox is like it's a huggable companion. It's actually it helps people sleep better by regulating their breathing. So that's what Somnox is. And the app, we have an Android and iOS app which communicates with the Somnox through BLE. Okay. And in this screenshot, what you see is that in the app, you have two Somnox devices added. And now let's assume that you have a new feature now where you set one of them as active. So that's what you see in the screenshot, that you have this active label on the currently selected one. So let's say that as a starting point, you had a table, with this schema where you have like a device ID and the user that it belongs to. And then you had this last paired when it was last paired. And now you want to add this column, is active. You want to add the column to indicate that, hey, this device is active. So this is a migration. And when you add this column, you want to set its default value to something reasonable. In our case, we want to set it to true for the device which is most recently paired. And for the other device, we want to set it to false, right? I mean, you don't need to explicitly set it to false for the other devices because the default value is false. So let's see how you do this in Kotlin. Again, you just have multiple leaf SQL queries, right? Like you would first get the last pair device from database. The exact query would be like trivial, right? It would be like a select with some order by a clause. And if it is found, you set it in the database. But then you can also do all of this in one query, in one SQL query, which is like you have this subquery here, which is actually finding the last active, the last paired device for this user, and then is setting it to true. So we were able to achieve this in a single query, like instead of multiple queries. So now things start getting a little bit more interesting. So here, what we want to do is we want to have a constraint that at most one device can be active per user, right? We don't want it to happen that you set multiple devices active for a user at a time. So let's see how you would do this let's first look at one more look at the schema, right? So you have this table device, and you have a couple of IDs, like the device ID and the user that it belongs to, and then there's this is active column. Okay. Here is how you might do it in Kotlin or in application code. You first get the currently active device. Okay. notice that we are trying to, the function signature is like trying to set a device as active for a user. So we first see if there is already an active device for this user. And if there is, you might, like throw an exception, or you might deactivate it or something. And then you set the new incoming device as active. How would we do this in SQL? Well, this is where it gets, SQL starts shining. So what you're actually trying to do here is you're trying to set a constraint. So you don't use a query at all. So in SQL, this is done by setting a constraint. What we're using here is we're using this create unique index syntax, which is an SQL feature called unique partial index. So I think you might already have used stuff like unique constraints, and you might have created index or indices. But this is actually something called a partial index. So it's a combination of the two. And this feature is actually meant for the exact kind of use case that we have. So what we're doing here is we're creating the unique index on the user ID column, but only when certain other conditions hold true. In this case, where this is active is true. So what this does is it creates an index. It basically makes this constraint that only one for a user, only there can only be one is active as true. And this happens. This constraint is applied at the database level. So you cannot violate this, regardless of how you write your queries or how you call your, how you call your application code. And this also throws an exception if this constraint gets violated. Okay, so this is an example of the data integrity that I mentioned earlier in my talk. So let's move on to another example, which is to unpair a device. So the reason I bring this example is that I want to show how you can use SQL to do not just one query, but do multiple things in one shot. So the constraint, the requirement that we have is, you might have seen this, for example, in Slack, right? Let's say you're logged into multiple workspaces in Slack. And when you sign out of one workspace or you remove one workspace, you want another workspace to be selected, right? So this is kind of the opposite of the previous case, where we wanted to have at most one active device, right? In this case, we want to have at least one active device. So when you unpair, we want to try to find another candidate to set as selected. In this case, we are choosing the most recently paired device to set as active. So yeah, we don't want to have a situation where nothing is set as active. Okay. So this is how you would do it in Kotlin or in application code. You have, again, these leaf queries, you first get the currently active device and you unpair it. Like in our app, you cannot unpair a device unless it's active. So that's why we have this this logic. And then you find the candidate, which is the last paired device for this user, and then you set it as active. Okay. And how do you do this? As you see, you would need like 3 or 4 different leaf queries to achieve this, right? And let's see how you do this in SQL. So this is what it looks like. It's kind of equivalent to the application code, but just it's written in SQL all in one place. So you first deactivate or like unpair, you first unpair the currently active device. Basically, you delete it, you delete the row. Then you find the candidate, which is the last paired device for this user. And if it is found, you set it as active. But you might have noticed in the previous slide that we had this with syntax. So what is this? So we did not use a subquery in the previous slide. So this with is actually another SQL feature. It's called common table expressions, and it's a more readable alternative to subqueries. So we could have used a subquery for the previous in the previous slide, but subqueries involve nesting. We did have a subquery in earlier in the talk, and in that case it was fine. It was just one level of nesting. But this common table expressions are much more make your SQL much more readable if you have lots of lots of subqueries and nested subqueries. So that's what this with syntax is. Of course, I've only been talking about the advantages, right? But there are, of course, like cons to SQL. The biggest con, in my experience, is that SQL does not compose. So we look at an example of this in the upcoming slides. The other disadvantage I found is that if you have, a lot of collection manipulation happening, like this mapping and filtering and stuff like that, then I have not found it to be like very readable. So this is true even if you're loading data from one table in the same database and then like copying it into another table in the same database. Even then, I do feel that using an application code is simpler. So let's look at another example. Right, this is a screenshot from the dashboard feature in the Somnox app. And what you have here is, like you can set the duration of a program, like a breathing program. That's what this 60 minutes is. You can set the breathing tempo. It's the breathing rate, basically. This 12.5 is like how many breaths per minute you want the Somnox to breathe at, And then the last one is an intensity. So what we have here is we have this table where we have a couple of columns that are like the primary key. And then you have a few more columns that, these are the properties that you want to set independently. And the requirement that we have is that the first time the user makes any change, let's say the user changes the duration. At that point, we need to create a row for this device and user in this table. At that point, you want to create a row. And later, any subsequent change, you want to only update that single column. Right? And I think like this is also quite a common scenario. So this is how I would try to do it in SQL. So first you have this query that ensures that a row exists for this user and device, and that is this ensure dashboard row query. And this is just a standard insert or ignore query. And once that is done, you would then update the single column. In this case, you're doing the set duration. You're doing this set duration, which sets the value. And let's say you if you want to update the intensity, you would do the same thing. Just set a different column. Now here's the problem with SQL. There is no way to call the first query, like there's no way to call one query from the other. What you would have to do is you would have to copy paste this entire insert or ignore, when you update the duration. And again, you would have to copy it, the whole thing again, when you're calling this update intensity. So there is no way to reuse. So SQL queries do not compose, or at least I have not found a way to reuse them. It might be possible, I don't know, but I have not found a good way to do that. But how would you do this in application code, for example, in Kotlin, right? We are just calling these leaf queries one after the other in a transaction. And similarly, if if you had to update some other property, it's the same thing. And notice how we were able to reuse the query that ensures that at least one row exists, right? You're just reusing it. This is like kind of the basic programming concept of function reuse, right? Yeah. So this is one example where using an application code, like doing this in application code, is way more reusable, maintainable, and readable. But until now, we have only talked about SQL, like database tables itself, right? But for quite a long time, actually, in the Somnox app, you could not add, we did not have a feature to have multiple devices paired. So you could only have one device. You could only add one Somnox in your app. And at that point, we were not even using a table. We were not even using a database. So we were saving your properties in like shared preferences on Android and user defaults on iOS. And then at some point, we introduced this feature to have multiple Somnox devices added. And we moved to a database. And this feature actually brings us to like some other situations where SQL migration does not work. Of course, this is by design. I don't want to point this out as a flaw of SQL or migration, but this is just by design, right? And that is migrating from like some other persistent mechanism like key value storage, shared preferences to a database. So of course, you cannot do this entirely as an SQL migration. You need to use application code for this. We also had in the Somnox app previously, it was in Android and Swift. It was in Kotlin and Swift separately before we moved to multi-platform. So it was, some of the data was in a room in Android and GRDB in iOS, and then we decided to migrate all of it to SQLite. And for this cross-source migration, there is SQLite does have this attach concept, attach syntax. So you can theoretically do this, but we decided to actually do this part in app code, in application code. And when doing this, right, when doing this kind of manual migration, you need to keep track of the status, and it's actually very convoluted. Like you don't have to go through all of these bullet points, but you need to manually keep track of the status every time the app starts. On app start, you need to check if the migration is completed. In this case, I say it has to be a table to keep track of the migration, but it could be any persistent mechanism. It could be like it could be a file or a shared preference. Like, so you run the migration. Once the migration is complete, you update this persistent state. It's just a complete mess. It just does not scale. Because let's say you had 10 new features, right? Then you need to keep track of this every time. Your startup code is a mess. You don't know when to delete this row, these tables. But then you can also do this in using your library. I'm showing SQLite as an example, but you can also do this in Room. And the advantage of this is, SQLite, you have this after version, right? So you can run specific code when your schema reaches a specific version. And at that point, you know now that your tables have been created, and you can run your migration, you can run your Kotlin code to import from shared preference into your database table at this point. And this, you delegate all this tracking status, everything to SQLite. And I did not show an example of this, but this also unlocks unit testing of your migration. If you had to do this, if you kept track of the status manually, then it would be like quite difficult to write unit tests. But in this case, you can write unit tests for this. So in your unit test, you can just call this database.schema.migrate function, and then you can write your assertions. Yeah, so that's SQLite. So how do you debug this kind of thing? In application code, you can just put a breakpoint, right? But with SQL, you cannot. So Android Studio has this database inspector. It also works with it's marketed as working with Room, but it also works with SQLite. And it's a UI plugin in your Android Studio. You can see like all your rows. You can see all of that. And this also works live. So if you make any change, if you exercise a part of your app that makes any change to the table, you can actually see that live. In iOS, Xcode has this download container. You can download the container for your app, and then you can copy your database file, or you can open it in SQLite browser or any third-party tool. I have not found a way to make this work live, so it's kind of not that easy to use. But of course, it's there if you want to really debug some problem. So in conclusion, I would say use SQL as much as possible, for expressing constraints. If you want to migrate with default values, if you want to do cross-table queries. We did not look at an example of this today, but if you have joins, if you're using multiple tables, thankfully neither Room nor SQLite use implicit joins. Implicit join is a concept that was there in like other libraries on the backend, like JPA. And like you would not know when a join was happening, like when a foreign table was being loaded. So thankfully, this is not possible either in SQLite or in Room. So you have to be explicit with your joins. But still, I would, if you have this kind of, if you have cross-table queries, it's better to make this explicit in SQL. And of course, where data integrity matters. And when not to use SQL, the biggest example I found is when you want to reuse queries, like we had in the example. Then if you want to do cross-source migrations, and if you want to do any collection filtering or mapping. So that's the conclusion of my talk. None of these snippets or this presentation is right now anywhere, uploaded anywhere. So you can follow me on my socials. If I do have a plan to upload this snippet somewhere, and then I'll post the link to that on my Mastodon. So you can follow me there. And yeah, I think we are almost at the end of time, and I open it up to any questions.
Anyone on the New York side? I guess from my side, I have a question around performance. Like, going from having queries done on the database side versus making multiple calls. Did you do any metrics around that to see like is it a lot more performant, or it's just a matter of keeping everything on one side?
No, I mean, like, at least on the mobile side, there was no, like, we did not do any performance, like I mentioned, right, because we had very few rows to begin with. On the back end, like I did write a blog post about this. It's not directly related to this, but we were using some other, like Juke is a database library, and we were using like that library to construct the queries, and it led to having a very very poorly performing query. This was not the fault of the library. It was a poorly written query, but it would be easier to spot if the query was written in SQL versus using some Java constructs to construct the query. So I did write a blog post about this, and yeah, I can share it in the chat later.
Yeah, sounds good.
Yeah, New York, we don't have any questions so far, but great presentation. We were just wondering why you didn't use Room, and then we realized, oh, it's KMP.
Yeah. KMP is Room. Room is KMP now, but at the time it was only SQL Delight. Yeah.
But even now, I found it pretty difficult to use Room. I think I had to also use SQL Delight for my own app that I built.
Yeah, there is this discussion always, right? There are situations in which Room is better. For example, this auto migration, Room has this auto migration. But personally, I recommend to use SQL. Not like in this case, we were only talking about using SQL to write your queries, but I also recommend to use SQL for your data definition, like for creating your tables, which is not the case in Room. In Room, you would be using Kotlin or Java to create your tables. And I recommend to use Room to use SQL also for that. Let me quickly pull up. This is what my blog post talks about, and I'll pull up my blog post and like post like post that blog here quickly. Yeah.
Karen, Joy,
Yeah.
how have you found the opportunities with dealing with the different variants of SQL in this particular way?
Yeah, that's a good question. So all of my examples were with SQLite, right? And some of these things, the answer to that is a lot of these things, a lot of the syntax that I showed today, it kind of is reusable. For example, on our backend, we used Postgres, and many of these things do carry over, but not all of them. One thing that I did not show is I just showed you. I just added the links to the SQLite documentation, right? But there is another thing that we need to deal with as mobile developers, and that is maybe I should do this in my future talks, which is many of these features were introduced in like some recent versions of SQLite, right? So then you need to worry about your min SDK, right? For example, hey, I'm using CT, but does it work on, let's say my min SDK is, I don't know, 28 or 29, whatever, So you need to think, hey, does my version of SQLite have this feature or not, right? Whereas on the back end, it's not that, Postgres is evolving very quickly, and on the back end, this is less of a concern because you can keep updating your version of your database. So that's one. Yeah, but there are other there are small syntactical differences. Yeah, you need to deal with them when it, like in Postgres, there is this timestamp database, timestamp TZ, timestamp with time zone, and that like in SQLite you just need to use an integer. So there are these differences, but overall, when it comes to the query itself, I have not found too many differences.
Okay. Yeah. So it's interesting. Have you looked at whether any of some of the, quote, agents or large language models or pieces might be an interesting interface that says, well, I'm here and I'm there now. Which way do I go through this path, rather than just use the human mind for everything and a great experience that clearly you have.
Actually, yeah, it's good that you bring up. So actually, I'm not an SQL expert at all. So I only very recently started, leaning on the SQL. So I actually used LLMs to help me find, like, hey, this is what I want to achieve, and this is how I'm doing it in application code right now. Like, what would be the best way to do? Like, is there a way to do this only in SQL? I did this, I don't know, 5 or 6 months back, and at that time, it was hit and miss. Like in some cases, the agents led me down the wrong path. In some cases, they were able to point me to like, hey, you can do it. For example, that's how I found out the CTE example, and that's how I found out like the unique partial index. But in some cases, they just led me astray. But yeah, so the way I've been doing it is to just use LLM agents more as like a sparring partner, and like figure out if there is a way to do this in SQL, in pure SQL. Maybe today, in 6 months, the AI space has exploded, right? So maybe if I had to do this today, I might do it in a different way. I don't know. Yeah, I think it might be interesting to like, yeah, to paste both the Kotlin code and this and like try to get agents to tell me which is better and why. I don't know. Maybe I should try that in the future. Yeah.
Well, it's interesting to take a look at where we are today looking at things, and to remember that all of this started a little IBM project called Future Systems in Menlo Park, California. As my sons would say, back in the caveman days. And there were only 2 things that came out of that. IBM wanted to get the next computer, but the customers owned the IBM instruction set, so it shopped. But the set theory for structured query language came out of that little Menlo Park area. So it's interesting how much of a life it still keeps moving on.
Yeah, actually, when I joined this call, Zhao was already having her talk about agents, right? And I was thinking, like, my talk is going to be, ancient. There's no AI or anything. If we are talking about SQL, which has been around for like, I don't know, 50, 60 years. It's interesting. Yeah.
Well, it's nice to see how deep you've gone into this and how to bring it back up to someone who hasn't gone as deeply as you, to remind them, there's a lot of capability here. So I appreciate it. Thank you.
Thanks.
All right, awesome. Thank you so much for the talk. It was great. And, again, thanks for coming and presenting.
Thanks.
All right, awesome. So for everyone who's still online, we will be having our next meetup next month. Topics to come. We are internally planning, so look out for our meetup page. All right, with that, unless New York has anything to say, I think we'll end up the call here.
Yeah, no, we don't have anything to say. I know it's a cold, rainy day, snowing, so we're just gonna head home. But thank you so much to our amazing speakers.